Okay, well today we're going to be talking about slope-intercept form. Okay, we're going to focus on today to write linear equations using slope-intercept form. Okay, and our standards for today is A1.2.2 and A1.2.3. Now we're going to be focusing mainly just really on this slope and the y-intercept on this second one, and more of this will come in with looking at graphs. Okay, so the first thing we need to know is what a parent function is. So we're making a lot of connections between what a parent function is to different functions as we proceed through. Parent function is the simplest form of a particular function. So for an example, that would be like to say y equals x. That is the simplest form of a line. Now we have examples of branches off that. That would be y equals x plus 2, which is a graph of the line shifted up 2 units. We could say y equals 2x minus 3. Now what this does is it stretches it vertically and moves it down 3 units. So because all these have a foundation of an x, it is reflected back to the parent function. Okay, so the parent function is the basic of that family. Another family would be to say y equals x squared. Okay, so that's a whole nother family. Keep that in mind. But if I were to put that as squared here and here, these would now be family members of this y equals x squared function. The second thing we need to know is what the y-intercept is. Now what the y-intercept is essentially where we intersect the y-axis. So there's the y-axis, and what we're saying is where we cross that line. That's what that is. Okay, so we are going to focus on that, and we would say that y-intercept we cross, and that becomes a big component of what we're going to do. So we need to keep that in mind. Okay, so the first thing we have here is slope-intercept form. Right here is the formula for slope-intercept form. This is the biggest thing you need to know. When you write slope-intercept form, it will always be y equals something x plus something. Okay, the somethings are going to change. Well, this m is our slope. So I've been hitting that up early and writing it m equals a lot of different places. Okay, the b is our y-intercept. So now this is kind of what I always say in class, that we're mathematicians were real original with this because we called it slope-intercept form, and in order to write this we need to know the slope and the intercept to be able to write this. So one way would be y equals, and the slope is 2, so we'll say 2x, and let's say we cross at -1. So right there's our equation, and we just be able to throw those things right in there. Okay, so let's test this out and let's see where we're at. Sorry there, I kind of had a typo. I meant to erase that and I guess I didn't. Sorry about that. What are the slope and y-intercept of the graph of y equals 3x minus 2. So again, let's write this up. Y equals mx plus b. We want to keep that in mind. Now m is real easy. Our slope here is always in front of the x. Okay, as long as it's 1y equals. So our slope is 3. Our y-intercept is got to be plus b. So what we have to do is we actually have to change this to plus the -2. Okay, so we just change that to plus the -2, which means our y-intercept is -2. Okay, so let's move over to the other one. We say, all right, 2y equals -x plus 10. Well, it's not 1y. So what we have to do is we have to divide everything by 2. We get y equals, and again we get 1/2 x. Same thing as x over 2. It's just -1/2 x. And then it's plus 10 over 2, which is 5. So now we can go through and say, well, our slope, our m, is a -1/2, which is fine. We just have a rise over run. that is a fraction. And then our y-intercept is telling us we're crossing at 5. So pretty simple. Okay. So go ahead and do this one. Keep fractions, fractions. Keep decimals, decimals. Okay. Problem number 2. Let's look at this. So we want to know what is it in slope-intercept form if they give us the slope is -4/5 and the y-intercept is 7. So we write y equals mx plus b. So when we get done, I should have y and I should have x. The other two letters change to their appropriate numbers. Okay, so they told us what slope was. So all we have to do is say y equals -4/5, x stays in there, and then it's plus the y-intercept, which is 7. So real simple. We just basically plug in these values into their appropriate spots. Okay, so here's another one for you. Go ahead and do that one. We'll check those tomorrow. So as we go through problem number 3, which equation represents the line? So how do we figure this out? Now a lot of people were struggling with this. They said, well, I didn't know where the points were. Again, what we're doing is we're looking for where does it cross this little grid, okay, where that grid kind of crosses. So it looks like there's one right here, looks like there's one right there, looks like there's one right there, right there. So we got plenty of points to go by. You're just looking for where those cross. So the first thing we probably want to do is just identify our y-intercept. That seems like the easiest. Y-intercept crosses that line. It crosses at -2. So that means A, see you later, B, see you later. We're down to C or D. So we're down to a 50-50 shot here. And now what we need to figure out is what is our slope. So we count. We say what is our rise? Well, we rose 2, ran 1. We rose 2, ran 1. Okay, rise over run, it's 2, which means our answer is D. Okay. So here's another equation that I want you to work on. Here's the line. I want you to go ahead and figure out what that is. You're just gonna, first thing you want to write down is y equals mx plus b as you go through. Okay, we'll go ahead and stop right there. It's kind of a long section. I want you first to know how to write it in slope-intercept form. So we're going to drill that tomorrow in class. And then we'll get into doing the graphs of them and doing modeling. Okay, so we'll go ahead and stop there.